Hello. In Unit 3 of our course, we traced out a story of the nature of light. And that was a fine story. In this unit, we will start by tracing out the story of what everything in the universe is made of. Now, have you ever wondered? We have so many different things around us. The stars, the planets, the earth, the rock, the minerals, the water, humans, and so many things around us. Have you ever thought of what are these things made of? In fact, this question has been asked by people from very ancient times. People were really wondering, what are we all made of? What is the basic constituent of matter? Now, we're going to trace out the story of that and see if we can answer that question satisfactorily. Well, do we have anything to go by? In the 5th century BC, a philosopher called Leucippus suggested that all matter, that is, everything including us, is made up of few simple building blocks. Just like a building is constructed by bricks, everything around us is made up of a few building blocks. Now, he managed to convince people, including Democritus, who was the leading philosopher at that time, who believed that matter was made up of small particles, so small that they cannot be further subdivided. Well, that is a good suggestion, is that right? Now, Democritus postulated that different substances has different properties because of the differences in the nature of these small particles with which they are made of, or he called them atoms. So the smallest particle that cannot be subdivided is called an atom. And Democritus suggested that different particles behave differently. Water, iron, copper, gold, all these things behave differently. He suggested that the atoms, the fundamental particles which make up these materials, may be different. However, his theories were not accepted by Aristotle. You know, Aristotle was a very respectable philosopher of 300 BC. Now, what did Aristotle thought? Aristotle thought that all matter was continuous, that matter is continuous, you can keep on dividing it. In other words, he said there is no basic particle which cannot be subdivided further. Is that right? Aristotle said matter is continuous, you can divide it and divide it and divide it until the end of days, whatever that is, and not discrete. Well, he advocated that every object on the earth was made up of some combinations of only 4 substances. Now, this is the Aristotelian philosophy. He said everything on the earth, well, of course, those days, earth was the only prominent object that we could talk about. It's made up of earth, water, fire, and air. Well, it took over 2,000 years for Aristotle's philosophy to be replaced by the concept that matter was not just composed of any of those general substances, but it is comprised of many unique elements. Now, we now know that everything that we have around is made up of some basic elements like hydrogen, carbon, oxygen, sulfur, etc. There are well over 100 elements that make up the substances that we see around us. Well, now here comes the postulate made up by Dalton, Dalton's atomic theory. Now remember, we are going to trace out the story of the development of the atomic theory, which took centuries to develop and took hundreds and thousands of scientists and wrote hundreds and thousands of books on it, and we are going to do it all in about 2 hours. All right, so I'm going to abridge that story, and I will make that story as comprehensive as possible. So I want you to follow through with me. In the early 1800s, the English chemist John Dalton revived the idea of the atom. Well, to him, the idea of the atom looked good, and he summarized his theories in 5 statements. Let's look at those statements. What did he say? Dalton said in his statement 1, indivisible minute particle called atoms make up all matter. So here he brought back the idea of indivisible basic particle that make up all matter. His second statement said all the atoms of an element are exactly the same. If you take an element like aluminum, all the atoms of aluminum are exactly the same. All the atoms of hydrogen are exactly the same. All the atoms of oxygen are exactly the same. Well, that is a good step forward. And his third statement said the atoms of different elements differ from one another in their mass. In other words, if one atom is small, another atom may be more massive. So atoms of different elements will differ in their mass. And his fourth statement said, atoms chemically combine in definite whole number ratios to form chemical compounds. Well, that is a big statement. That actually advanced the understanding of chemistry and physics a lot. Atoms chemically combine in definite whole number ratios. Now, you know, most people call water H2O. What does that mean? It means 2 parts of hydrogen combined with 1 part of oxygen, or 2 hydrogen atoms will combine with 1 oxygen atom to produce 1 part of water. You see, atoms chemically combine in definite whole number ratios. Hydrogen to oxygen in water is 2 to 1. All right. His fifth statement said, atoms are neither created nor destroyed in chemical reactions. He said chemical reactions are simply exchanging one atom from one group to another and not destroying or creating. Chemical reactions do not create atoms or destroy them, but simply rearrange them to produce one new substance from existing substances. Now, many scientists at that time were skeptical about these suggestions because atoms could not be observed directly. You see, if you want people to believe anything, the best way to make people believe is to make them see things. You see, in this course, I have been trying my best to make you see things, to show you demonstrations. You see, that is the most important characteristics of science. You see, learning by actually seeing. So most people were skeptical about the atomic theory brought forward by Dalton because these atoms could not be seen. It was so small. The discovery of electron by J.J. Thomson changed all this. So if we now talked about the first chapter of the atomic theory, the second chapter of the story is going to start with the work done by a very eminent physicist called J.J. Thomson. Now, what did J.J. Thomson do? J.J. Thomson